Welcome to Astronomy 104, the astronomy of planets. In this module, we're going to be digging deep. We're going to be looking at the early history of astronomy, but as we do that, we're also going to be looking at what science is, talking about scientific reasoning, the scientific method. And the reason we do that is because the way we practice science, it really did develop as people fought to understand what's going on in the sky. So this module, it'll provide us with a lens that we can use to look at all the scientific achievements that we study in this course. The module will start off with prehistoric astronomy. So you'll see examples of early cultures that studied the night sky and knew how to track the periodically recurring phenomena in the sky. Things like the sun moving through the background stars throughout the year. Also, as people began looking at what was going on up there, they also started to think up explanations for the things that they were seeing. And this process of data collection and sort of guesswork, guessing at causes that were supposed to explain the data, that was really the dawn of science. So we'll see how the ancient Greeks, after that, took science a step further in proposing that the things that people had been observing in the sky, that they were essentially explainable, and they began using logic to explore possible explanations and thinking up all sorts of different causes that might account for the phenomena that people were observing. So by far the most difficult problem that they had was describing the paths of the planets. The word planet comes from the Greek name meaning wandering star. As the name indicates, the planets' paths were really difficult to describe because the planets don't appear to be moving regularly through the stars. They wander apparently fairly aimlessly, and finding a description of using where regular motion would somehow conspire to appear aimless the way that it does proved to be a very difficult task. So in a way, we could say that the scientific method was born out of the difficulty of the problem of describing planetary orbits. So eventually, Claudius Ptolemy, in the 2nd century, figure out a fairly accurate description. He worked out a fairly accurate description of the motions of the planets. His model, it was geocentric, meaning that it was Earth-centered, the Earth not moving in the center, all of the planets and stars moving around it. It was based on hundreds of years worth of data that had been collected meticulously. Geocentrism also was supported by a lot of different observations that were taken to indicate that the Earth isn't moving. Ptolemy's model provided such a good description of planetary orbits that no improvement was actually made on it for 1,500 years afterwards. It was also completely wrong. So what you're going to see as you read through the learning material for this module is that the scientific method isn't a foolproof recipe for discovering the correct description of nature. Actually, by modern standards, it was very good science that produced the Ptolemaic model, and you'll learn that science, it's not even just not foolproof, sorry for the double negative, but it's not even genius proof. You should understand that the scientific method developed through brilliant insights of people who were not fixated on wrong beliefs. So it wasn't that they just really wanted to believe in something like the Earth being at the center of everything for whatever reasons that they had, and that was misleading them. but these people really sought a rational explanation of the phenomena, which is what we do in science, and it's what they did then. And so basically, they followed the same process that scientists do today, and what they were misled by was limited information, which is a problem that will always exist in science. So the reason why this happens is that we don't have a way of determining what's right with absolute certainty. But what we do as scientists is we can determine if something is wrong, if one of our guesses is wrong. It's an important concept that all physicists and astronomers keep in mind. It means that even through the best scientific practice, brilliant people can have completely wrong ideas about nature. They can develop completely wrong ideas about nature. But what it also means is that by continuing to search for new knowledge and continuing to measure things as precisely as possible, which people have been doing for thousands of years, we can discover which ideas have been wrong, and we can potentially fix them. So as we'll see in the next module, that's what happened in the scientific revolution. And I just wanted to end this video with what I think is a pertinent quote on from Einstein, and which I hope you'll find inspiring. So he said, "When I think about the ablest students I've encountered in my teaching, namely those who distinguish themselves through independence of judgment and not through sheer agility only, so I state of them that they had a lively interest in epistemology, which is the theory of knowledge. They gladly entered into discussions about the aims and methods of the sciences and showed unequivocally through persistence in advocating their views that the subject seemed important to them." So enjoy the learning material and see you in the discussion.